Shortest video ever. Here we go. Newton's laws. If all forces, the first law is if all forces, okay, acting on object balance, that means the sum of all forces equals 0. That's a sigma right there. Okay, sigma for like saying the sum of all forces. Okay, this is the sum of all forces on an object balance or equals 0. Then object, okay, moves with constant velocity, with constant speed, and constant direction. Okay, so what's happening, right? So an object does not need to have a net force in order for it to move. It just needs to have a net force for it to accelerate. Okay, so there's a huge misconception. People think that hey, it needs to have a force on it to move. No, it's not true. It's just because it needs to be able to accelerate. Okay, it needs a force to be able to accelerate. Newton's second law is pretty famous. It's just F net equals ma. Okay, and the original form of this is A equals F net over m. Okay, you'll probably see it like that on the formula sheet. Okay, F net is what does the force. Okay, what does the forcing? Okay, this is what we call the agent of the force. Okay, and then m is what we call the object, is what being forced. What is being forced? Okay, is the object. Okay. Newton's third law is is pretty long-winded if you go for like a better definition of it, but simply if object A exerts a force on object B, okay, then object B exerts a force on object A with same strength, okay, same strength, opposite direction, okay, at the same time, and both same type of force. So very important. When you walk on the ground, you're actually exerting a friction force on the floor, and the floor exerts a friction force back on you. If I push somebody, right? If I smack their face and push them, I am exerting a normal force on their face, and their face exerts a normal force back on me. It happens for the same time, the same amount of time. So only while my hand is in contact, right? It's the same type of force, same time, opposite direction, same strength. Okay. Why is it not equal and opposite reaction? Well, it's because you really, really need to understand that these are forces acting on two different objects. Object A is acting on object B, and object B is acting back on object A. Okay. Very, very important for you to understand that, because otherwise you're going to get things about Newton's laws wrong. All right. There you go. That's literally it. All right.